All right, students, here we go. We're going to be talking about volume of cylinders today, digging deeper into our three-dimensional geometry unit. Talking specifically about volume today, so how much space is inside or how much space a shape takes up in 3 dimensions. And then also talking about cylinders today, which is kind of like the prisms we've been talking about, but rather than having polygons as bases, they have circles as bases. You might think of like a Pringles can or an oatmeal container, or like a soup can. Those are all going to be examples of cylinders with 2 circles, top and bottom, and then a rectangular piece that wraps around. We're going to take our formula for volume from Prisms, which is volume equals base area times the height. But we're going to modify that today. Since the base shape is always going to be a circle, we can actually say volume equals pi times the radius squared, which is how you find area of a circle, times the height of the whole prism. So this gives us base area, or the area of the circle, and then times height of the whole thing. I have an example of a cylinder right here where you see the base shape is this circle, top and bottom, and then the rectangular piece that wraps around. We're going to be using that to find volume today. So here's an example. First of all, that we have a radius of 4 centimeters and a height of 13 centimeters. So let's work this out. Let's start with our formula. Volume equals pi times the radius squared times height. Now, just a quick review on pi. Pi is, of course, the ratio of circumference to diameter in any circle, and we know it to be pi is about 3.14. That's going to be the approximation that we're going to use for our solving for our calculations today. So let's work this out. We got volume equals 3.14 for pi. Radius is center out, mind you. You might see the diameter, but radius is going to be the center out, so that's going to be 4 squared, and then times the height of 13. One spot that you might make a mistake is not squaring your radius first. You must square your radius first, and that is taking 4 times 4, not 4 times 2. 4 is a factor twice. 4 times 4 is 16, so make sure you do that. Square the radius first. We have 3.14 times 16 times 13. I'm going to grab a calculator here. And be careful if your calculator has my calculator has a pi key. If you push that pi key, it's going to give you a lot more precise, a lot longer approximation for pi than just 3.14. So probably don't use that pi key, just use 3.14. Clear that out. 3.14 times 16 times 13. 653.12. So volume of this cylinder is 653.12. Label is centimeters cubed, cubic units, because it is volume. That looks good for that one. We'll be finding volume of cylinders a couple more times here. Let me get this out of the way. There we go. Next example I have for you, you might be able to tell the difference. We're looking at 14 feet as the diameter, not the radius. So that's the change from the last problem. Be aware of that. If this equals the diameter, we're not going to use it for radius. We're going to find the radius based on the diameter. So if we have 14 all the way across passing through the center, from the center out must be half of that, or divide by 2 to get 7. So the radius actually equals 7 feet. Here we'll be using 7, not 14. Let's jump right into our formula. Volume equals pi r squared h being multiplied. So volume equals 3.14 times the radius, 7, not 14. 7 is the radius, times the height. Keep in mind that you got to square your radius first. So So we'll go volume equals 3.14 times 7 squared, which is 49, and then times the 15. Grab the calculator here. I'm going to go 3.14 times 49 times 15. 2,307.9. Label is going to be feet cubed, or feet to the third power. That's how you're going to find volume of a cylinder if you're given the diameter instead of the radius. So if you're given that diameter, make sure you use it to find radius. Our formula is only in terms of radius. Moving on, we're going to find number 10. This is actually on your practice page. Number 10 is a application problem. It says, Bo was comparing two cylinders that both had a height of 5 centimeters. The first had a radius of 10 centimeters, and the other had a radius of 20 centimeters. How many times greater was the volume of the larger cylinder? Saw a little bit of struggle on the problem with Prisms about this, so I wanted to get through it together with you today. The idea is that we're going to find the volume of each and then use that to compare. So if we find the volume of the first cylinder, volume of the second cylinder, then we can divide them or compare them with each other. So let's go ahead and do that. Volume of the first cylinder is going to be volume equals pi times the radius squared times the height. Volume of the second cylinder is going to be volume equals pi times the radius squared times the height. So the height is the same, but the radius in each is different. So let's see how that affects our calculation. First of all, we have 10 squared. That's going to be 100. So now we have volume equals pi times 100 times 5. I know 100 times 5 is going to be 500, so we'll go 500 times 3.14 is going to be 1,570 cubic centimeters for the first one. Let's find the second one. If we go volume equals pi times 20 is going to be 400 times 5. 400 times 5 would be 2,000. So if we go 2,000 times 3.14, that's going to be 6,280 cubic centimeters. Now to find out how many times larger one is than the other, if we take that 6,280 and divide it by 1,570, we will have our answer. And look at that, 4 times larger. So the larger one is 4 times the smaller one, 4 times larger. And that's going to be our answer there. All right, let me know if you need some help. I'm available via email or private comment. Thanks for watching.